Hello everyone, welcome back. So in this video, we are going to understand today contest problem, right? So this is in the daily series. We have given an integer array that is called nums, and its size is n, right? Means we have given an array of integer nums, and what we need to do, we have to find the length of the longest contiguous subarray, right? Such that the bitwise and of all the elements is equal to the maximum possible AND, right? What is the maximum value of the bitwise AND, right? Means we have to find the length of the longest continuous subarray such that the bitwise AND of all its element is equal to the maximum possible AND from any subarray in the array, right? That we have given. What we have to do? We have to it is saying let k be the maximum value of the bitwise AND of any subarray nums, right? Then consider only the subarray with the bitwise AND equal to k. It means the bitwise AND of all the elements that we have in the array, right, is equal to you can say k, right? So we can say is equal to what? The maximum possible bitwise AND from any subarray of nums, right? I hope you understand the problem, what the question is saying that. Okay, so you know what is the subarray and how we can create the subarray. We should also understand what is the bitwise AND of an array, right, which is the bitwise AND of all the numbers in it, right? Very first, the concept is saying that the bitwise AND, right? The bitwise AND of a subarray means we are going to apply the AND operator. Give me 1 second, guys. So very first, I want to talk about the bitwise AND. Okay, so maybe some of you are beginner, right? So I should also talk about the bitwise AND. What is a bitwise AND? So if you remember in your college time, right, or if you are in the college, there is an operator AND, right? So when we apply the bitwise AND, means we are using this operator. So the bitwise AND is a binary operation, right, that compares each bit of the two numbers. Understand? Means it will compare the two bits, two numbers bits, you can say, each bit of the two numbers, you can say, right? And it will return either 1, right, or either it will return 0 if both bits are what? 1 1. If like this, if both are AND, it will give you 1. In other case, like if we'll take 0 0 1 0 0, right, these cases it will give you 0, but this case it will give you 1. Remember? So this is called AND operator, or bitwise AND we can also say. Let's understand through an example. Okay, let's take a two integers. Can we take a is nothing but us, let's suppose 6 will take, and b will take 5, and we take, and I want to apply a and b like this. So what it will give? So for this, we know that what will give you the formula that I am talking from the last 3 days is 8421, right? And I hope you understand this formula to when we are converting the decimal into binary. So from the 6, how will we make the 6? 4 plus 2. So what we will do, we'll take, let's suppose 0, we'll take 1 1 and 0, because only 4 and 2 will be 1 and rest of the thing will be 0. Similarly for 5, we'll take 5 and 1, 4 and 1, right? So we'll take 1 0 1 and this will be 0. If you'll do the sum, what you call not sum, and if you apply the AND, what you will get here? 0 and 1, what you will get? 0. 1 and 0, what you will get? 0. 1 1 will get 1, and 0 0 will get 0. So this forms what? This forms only 4, right? It means this is 4. I hope you understand the bitwise AND, right? So whenever in your mind it comes the bitwise AND, you should understand only one thing. Okay, what is that thing? That if I am comparing the two bits, if both are 1, it will give you the 1. Otherwise, in the case if you're comparing 1 0 0 1 or 0 0, all will give 0. As you can see, 0 0 0. Only in the case of 1 1 we will get what? 1. And so we will represent this binary into decimal back. It will give you 4. I hope you understand, right? Let me clean this. So let's try to understand with this example. Okay, so we have given what? The bitwise AND. So the bitwise AND of a subarray means what? We are going to apply AND, right? Operator between all its element. If any elements we have given, right? If any elements of we have given in the nums, right? So all the elements, right? We will apply a AND operator between all the elements. Let's 1 2 3 like this. So we'll apply like this. If 3 elements are there, we will apply this. So this is the question is saying. Okay, very first what it is saying, we have the bitwise AND. The bitwise AND of a subarray means we are going to apply this AND operator, right, between all the elements of the nums, and the bitwise AND becomes smaller or equal, right, when we apply to the more numbers. So right, either it will become what? Smaller when we apply the bitwise AND operator, right, in anywhere, right? So it will become what? Either smaller or equal, right? As you have seen, we have applied 6 and 5, right? So when we apply this, it will become either smaller or it will become equal when we apply to more numbers. I hope you understand, right? So this is the concept of the bitwise AND, right? So the maximum bitwise AND over any subarray is just the maximum number of what? The array, right? So if we'll take, let's suppose, if we have a less number of array in the number, right, it will give the less value. If we'll have the more value, we'll get the more value, right? So the maximum bitwise when we'll apply on uh, any subarray, right, it is just a maximum number should we have in the subarray, right, or in the array, you can say. Let's call, if a we are going to apply on the b, right, it should be less than equal to a. This is the concept we have, right? Or if we apply a and b, let's suppose, it should be less than equal to b. So this is the concept we have in where? In the bitwise AND, either a smaller or equal. So when we apply the AND operation, right, it gives you what? It becomes either smaller or equal. So you can say like this, when we apply on the more numbers, it will be look like this. So can we say, so you only need to look for what? The subarray where all the elements are equal to the maximum number, right? Because that's the only way the AND of a subarray can stay at the maximum value. Can we say that? We can say that, right? Let's understand an example. Okay, so let's suppose if we'll take the nums. Okay, if we'll take the nums, let's suppose we'll call 1 2 3 3 2 2. This is the number we have. Okay, so in the very first step, right, we'll say find the maximum element in the array, right? Can we take what is the maximum array element here? Max value we can take what? In the step 1, max value let's take, and the max value what we have in this array is nothing but 3. We can find it. If we want to find the max value element in this array, we can find it. That is nothing but what? 3. In step 2, now look for the longest continuous subarray where all the elements are equal to what? 3, right? What are those elements? Let's mark it. Let's suppose, one second, can I say, if this is index is what? 0 1 2 3 4 5. So these two indexes at here and at here, right, what we are getting? 3 3. But if you talk about this value also, what we are getting, just think, at 3 and at 4 we also getting what value, right? So whenever we talk about the index, so can we say the max value will be at where? At 3 3. So this is your max value zone. So from 2 to 3 we'll say is a max value, right? So the subarray will take these two. We can take this one also, but no, this is not equal to 3 3. If we'll talk about only the max one, what, where is the max one? 3 3. So this will be take a 3 3. So this is the max value zone, right? So what we need to do, we have to find the longest continuous subarray where all the elements are equal to what? The max value. And this is the subarray, right? Can we say that? Okay. So the subarray 3 3 is at where? Can we say that? Index 2 and 3. Index 2 to 3, you can say. Index 2 to 3, right? We have this subarray. And this subarray is the longest contiguous. We are not changing the index, right? The continuous, what you call sequence of Maxwell. Can we say that? So if we will apply now the bitwise AND, or you can say the AND operation, okay? So if you apply of these 3 3 subarray, right, it means it will give you what? 3 and 3, and which is equal to what? 3. If you apply 4 3 8 4 2 1, right, this should be 1 1 1 1. Let's suppose call it 0. This is also 0. So 1 1 0 0. In both cases we will get 1 1 and 0 0. Again it will give you what? 3. So you are getting 3, which is equal to the max value. Is it equal to the max value or not? It is equal to the max value. After applying the AND over the subarray of the element, you are still getting what? Equal to the 3 that I told you, right? Either it's smaller or equal. It is coming equal. I hope you understand, right? So can I ask one thing here? Okay, that this is the maximum value that we are getting here, right? The longest continuous subarray we have here, right? That is gives you the 3, which is equal to the max value. So what are the other candidates which is equal to the max value? Let's call it 3. If we'll take only one element, one subarray, this subarray, there we have taken 3 3, right? That we have already checked. This is the longest one, right? Then we'll check what? Let's call it 2 2. Can we make from the 2 2? If we apply the 2 2 over the AND, right, it will give you what? 2, which is not equal to the max. So we'll not, we will discard this one. Okay. So we'll say 2 value we have is 3 and 3 3. That gives you what? The maximum value, which is equal to the max value. Can we say that? So the final answer we can say is we have the longest, the length of the longest subarray where all the elements are equal to what? 3, right? Is how many? We have 2, right? And that is our answer. Because see, the question is saying that return the length of the longest such subarray. And what is the such a subarray? Is 3 3. So if you see 3 3, if is in the what? In the array, what is the size? It gives you 2. So we'll return as a 2. So this is the question is saying. Okay. You can pause it here and you can try by yourself. So now understand the intuition. Okay. Very first, what we have given? We have given nums. So this is an integer array. And what we have to do? We have to find the length of the longest subarray, or you can say the longest continuous subarray, right? Such that the bitwise AND of all its element of the nums, right, is maximum possible from any subarray. Maximum possible from any subarray in the array, right? So if you talk about the intuition, means first of all what we should understand, we should understand how does and behave, right? Can we say that? First of all, understand that. So this is a bitwise AND operator, right? This will become what I told you, right? Smaller or equal when you add more numbers. When you add more numbers. Can we say that? I'm writing only for those who are beginner. Okay. For example, let's call let's write 7, right? If you apply 7 and 7, what it will give you, right? It will give you 7. You can apply 8, 4, 2, 1, and says for the 7 we can take all of these 3. So 0, 1, 1, 1, 0, 1, 1, 1. We'll apply the 1, 1, we'll get what 1, 1, 0, right? And that is why we are getting 7. Similarly, if you'll take 7 and 6, two element we will take. So we are taking what? 0, 1, 1, 1. And the 4, 6, what will happen? 0, 1, 1, 0. Can we say that? Now we'll get 1, 1, 0, 0. And this is what? This is 6. So we are getting what? 6 here. I hope you understand. This time let's suppose we'll take 7 and 6 and 5. What it will gives? So from here to here we have already seen, right? So 7, 6 and 5. If you will apply, we have got what? We have got 6. Now we will apply 5. Means 1, 0, 1 and this 0. Now apply the AND. We'll get 0, 0. This is 1 and 0. It means it will give you 4. Right? So if you keep ending the numbers, right? If you keep adding the numbers, you can say ending means you're applying the ending. Okay. So if you keep applying the AND operation on the numbers, right, the result never increases. As you can see, it is what happening, it is decreases. The result never increases. So it's either says the same or it drops, right? I hope you understand, right? How does the AND behave? So you have to understand the nature of the operation. Okay. Then think about what's the maximum possible AND. So the maximum AND of any subarray will always be some number in the array, right? Specifically the maximum number we can talk, right? Why? Because let's suppose we have X and we'll apply Y. We can say it should be less than equal to what? Mean X and Y. Whichever is mean, that will come. So any combination of the value we will apply, right, will always resulting in something less than equal to the max element. Can we say that? That we have seen already these things, right? So the maximum possible result from the AND, we can say if we'll apply any number, right? Let's suppose you're applying on X and Y, right? So it should be less than equal to the mean, right? So any combination of the value will always result in something which is less than equal to what? The max element. Can we say that? And so the maximum AND, we can say the maximum bitwise AND of any subarray will always be something, some number should be there in the array, right? I hope you understand the maximum number, how we can find it, right? So what is our logic? So to get the maximum AND, right, to get the what? Maximum AND subarray, we must only what we call, must only the element equal to the max number, right? Only the elements which is equal to the max number. Otherwise, what we will do? Otherwise, it will become what? Is smaller or equal to, right? Means to get the maximum AND, the subarray must consist of what? Only the elements are equal to the max number. Can we say that? Max element. Otherwise, the AND will be less than, it will be less. Can we say that? So the problem reduces to find the length of the longest continuous subarray where all the uh, elements equal to the max value. As we have seen, right, we are getting the 3 was the max value, right, and we got the 3 and 3 subarray, right, means we have to find the length of the longest subarray, right, where all the elements, right, all the elements equal to the max value. I hope you understand, right? So very first what we need to do, we have to find the what you call, if you want to apply the operation, right, what we will do, we will apply, we have to find the what we have to find, very first the maximum number, we have to find the maximum number or maximum element in the array. Can we say that very first? And for that what you need to do, just you will take the max element, we can say, or max value we can say is 0. You can take it as an integer, right? And for the loop you will get from what, for each on the numbers you will get all the elements from where, from the nums, right? And each time you will take math.max, right? So this max element have some value is there, max element, and this element, right? And you will get the result, max value or whatever the max element is there. We'll keep updating it. So you will find the max element. Very first what you need to do, find the maximum number in the array. Once you will find the maximum element, right, then what you should do, we should traverse again, and we should count the longest sequence of the continuous max value. Let's suppose we find the value that was 3, remember, then we will traverse again, right, and we will count the longest sequence. How we will find the longest sequence, right? Once you will find the longest sequence of what, continuous max element, right, it means give me 1 second, it means we are talking about 2, means we want to find the what, longest what do you call, longest sequence, right, longest sequence we can say of continuous max value. Remember, means we want to find 3 3, right? In that case you just need to what need to do, max length, because we don't want to create a separate what do you call, the subarray. But if we find the count, right, if you found the count, that will give you the its size, right, how many counts are there. So 2 count having same max value, and we can get it. So how we can get it, that we are going to understand. So very first what you need to do, you will find the max length, right, and the current length. From the max length and current length we will define 2 variables, right, and over the 4 elements, right, we can get from the nums. We will just check if the element is equal to max value, max element, you will increase the current you will increase this current count, you will increase it, and then you will find the max element. Just math.max you will get, and you get the max length. Once you will have both, right, you can find the result, right. Max will return from the max element you will return it, okay, right, because we are tracking the 2 elements. Let's try to understand from the code. So very first let's talk about this value, okay. So you got the max element till you got it, right, till that I don't think there is any problem, right, means we have to find the max value, and the max value is nothing but what, 3 we are getting, right. Now you have taken the max element and the current element, right. You will take a loop, right, you will check the how many numbers are equal to the length, means you will get 3 and 3, 2 times you will get which is equal to the max value, right. There can be many elements will be there in the array, right. I am not writing that one, only these 2 I am talking about from here to here, right. What we'll call, if the num elements is coming to the max value that we have find, how many are there, whenever we'll check here, right, what we will do, current will increase, current plus plus, right, we'll keep increasing the current. So current initially it was at here, let's suppose here, it was what? Initially it was 0. So when the first time came, current become 1. Second time it come current it become 2. Means current is 2. What is the max is there? Max is 0. Current is 2. Right? Means first time when current was 1, the max will become 1 because of this one. Again current is 2, max is 1. Now what will happen? Max will become also 2. Right? So the max you got. And then finally we'll return what? The max. We have to take else condition also. Why? Let's suppose 3 1 3, we do not have the continuous. There can be more elements is also there. Let's suppose x and y, we can say that other elements are also there, but this is not continuous. So let's suppose current start from here, right? So whenever current start here, the current will become what? 1. But we are not getting the continuous array. Means we have to reduce the count. When count will come here, current will become what? 0, and that will become this one. Okay, I hope you understand, right? And then finally you will return if both are equal, the max will return. That's all we have in this video, right? Let me know the time complexity and space complexity in the comment, right? Whoever is writing the right time complexity and space complexity, I'll give the heart, and I will pin that into the comment section so other can understand this is the right time complexity, space complexity. Please write time complexity and space complexity. Thank you guys. Thank you for watching this video. Let me know in the comment section that you understood or not. And I really appreciate you if you like this video, and support Expert Funda in your journey will always be there to help you. Thank you guys. Thank you for watching this video. Bye.